Hi, this is a lecture overview of Chapter 1.2. Every section that we cover this semester, we will give you a little small video clip, maybe 5 to 7 minutes or so at the most. And it's basically going to just give you a little overview. This is not a substitute for a full lecture. This was just a very kind of like cliff notes, if you will. So this is our very first one, and so this is from 1.2. So 1.2 is our first section in the book that we will be covering, and the title of this section is Quadratic Equations and How to Solve them. First of all, the definition of a quadratic equation, like I gave you in class, is a quadratic equation is of the form ax squared plus bx plus c equals 0. Where a, b, and c are real numbers such that a does not equal 0. So this is going to be kind of one of our friends for this course. We will actually do the quadratic functions a little later, and you'll see that the shape of this is a parabola. But what this is about is solving the equations. And the method of solving equations, and again, this is from intermediate algebra as well, and so this should be a review for most of you guys. But the methods of solving this is factoring, the square root method, completing the square, and the quadratic formula. Now, the reason the 1 and 4 had a little asterisk beside it is these are the two methods that we will concentrate on in this course. Remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, the factoring in the quadratic formula, each of them has their advantages and each of them has their disadvantages. Factoring is good because most people find that's easier to do. The disadvantage of just knowing factoring is they don't always factor. And so you'll need another method for that, and that comes up the quadratic formula. So the advantage of the quadratic formula is whether it factors or not, it always works. But the disadvantage of factoring, of the quadratic formula, is it's a formula. And as if all formulas, if you don't know part of it, it's like not knowing any of it. So if you miss one little part, for example, if you take the square root of b squared minus 4ac, by the way, b squared minus 4ac is called the discriminant. And if you forget the square on the b, then the whole formula blows up in your face. So the formula is all it's going to be good for is if you know it. And if you know it, all you have to do is punch in the a, the b, and the c of the equation back into the formula and do the simplification. So anyway, so that's the methods of solving. Again, we're going to be factoring in the quadratic formula for the most part. Okay, the types of solutions that you're going to get on quadratic equations are two distinct reals, which basically means you'll get two solutions. Neither one of them are complex, but they're all both different. Another one is a double root, just that means you have the same answer. So you still get two answers, but it happens to be the same number. And then the third one is two distinct complex solutions. And we concentrate on that in section 1.3. So anyway, so I'll give you three examples. And the first example, I'm going to do a factoring one. And the other two, I'm going to use the quadratic formula. So now the first one is 6 times p squared minus 1 equals 5p. Now, I set this one up because most of you guys will think, well, factoring is easy. Well, it is, but you have to set it up in the form of ax squared plus bx plus c equals 0. So in other words, you got to solve for 0, get it 0 by itself, in other words. And that one is far from that at this point in time. So the first thing you're going to do is you're going to distribute the 6. So it's 6p squared minus 6 equals 5p. So remember, 6 times negative 1 is a negative 6. A lot of people will forget to do that. Then you set it equal to 0 and put it in descending order. So you get 6p squared minus 5p minus 6 equals 0. Now, the a is 6, the p is negative 5, and the c is negative 6. And if that was using the quadratic formula, I would just substitute those numbers into that. But this one should factor, and so I'm going to factor this one. So 6p squared is 3p and 2p. And I know some of you guys have probably learned the AC method. I'm just going to do the guess and check method. If you know the AC method, that's great. If you don't, just do the guess and check method like I do. So 6p squared is 3p times 2p. And the negative 6 right here, so that one here is going to be 3 over here and 2 over there. And that's going to be a 9p, FOIL. And then this is 4p. And 9p and 4p combines to give you 5p if you subtract it just right. But this one's going to be a negative and this one's going to be a plus, and I think that'll work out for you. And the reason factoring is so nice is because once you get to this point, if you multiply it out, it should give you 0 either way. So this times this equals 0 only when this equals 0 or this equals 0. So 3p plus 2 equals 0, and 2p minus 3 equals 0. In this case, p is a negative 2/3, and in this case, p is 3/2. Now understand what you're trying to do here. You're trying to figure out what numbers make the equation work. So back in the original, if you put negative 2/3 back in the original equation for p, or the 3/2 back in the original equation for p, either one, the left-hand side equals the right-hand side. I'm not asking you to check that, but that's what's happening. So these are the two solutions. Now, in this equation, we'll use a quadratic formula, but it doesn't look like anything in this form. So what I'm going to do is I'm going to multiply both sides by x squared. That just makes it look like in the correct form. So x squared times 1 is x squared. X squared times the middle term is actually 4x because one of the x's will cancel. And then x squared times this is going to be 4 equals 0. Now, actually, this one factors, but I wanted to show you one that will use a quadratic formula with numbers that comes out really super nice. So x squared plus 4x plus 4 equal to 0. So if I use a quadratic formula, it's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, remember, a is 1, b is 4, and c is also 4. So I picked those numbers off the front of those terms. So you get opposite of b, which is negative 4, plus or minus the square root of b squared, which is 16, minus 4 times a, and a is 1, times c, which is 4, all over 4. Oh, it's actually 2 times a, so it'd be 2 times 1. Okay, so you get that equals negative 4 plus or minus the square root, and this turns out to be 0. 16 minus 16 is 0, so it'd be the square root of 0 over 2 times 1, which is 2. Now, plus or minus the square root of 0 is still 0, so it just turns out to be negative 2. And you're like, well, what's my missing answer? I should have 2 answers. Not always. Sometimes you'll get one answer, but it happens to be twice. This is what I was talking about a while ago. It's a double root. Okay, so it's a negative 2. Works, but it works twice. So the negative 2 is the solution. And then lastly, same concept as example 2, except I'm not going to multiply both sides by x squared. I'm going to multiply both sides by 4. And that's going to make the numbers come out nicer. Yeah, you could put a equals 3/4, b equals negative 1/4, and c equals negative 1/2. You could do that, and that'd be fine. The problem is the numbers come out really hard to work with. So what I'm going to do is I'm going to multiply both sides by 4. So similar like I multiply both sides by x squared just to make it come out really nice. And then 4 times this is going to be 3x squared. 4 times this is a negative 1x. 4 times this is a negative 2 equals 0. And so this one right here makes the a, b, and c really easy to work with. So a is 3, b is negative 1, and c is negative 2. Now, I'm not going to finish this problem because it's going to look very similar as example 2. So, but you put those numbers into the quadratic formula, you will actually get 2 answers, and they will be real again. So they just won't be as nice as the 2 numbers on the first. Probably going to get a radical in there. So, but like I said, this is going to be a very short one. So most of them are not going to be this long. I just had to introduce what we're going to do at the very beginning, and that's it.